Hello everyone. Today topic is dam and its types. Myself G DHARSHINI, Assistant Professor of Geology, A.D.M. College for Women, Nagapattinam. Okay, what we can see is introduction of dam, purpose of dams, and site selection for dams, and geology of dam, and what are the types of dam, and what are the parts of dam, and advantages of dams and environmental issues due to the construction of dams, and examples of dams in India, and conclusion. Okay, dams. A dam may be defined as an obstruction or a barrier built across a river or a stream. Dams generally serve the primary purpose of retaining water. A dam is used to collect the water or for store the water which can be evenly distributed between the different locations. The dam may be constructed of masonry or concrete. They can be constructed on any dam site where a natural foundation enough to bear the weight of the dam. Dams are generally constructed in the mountain range, the water, river, where the valley is narrow and the foundation is good. Generally, hydropower station is also constructed at or near the dam site to develop the hydropower. Definition. The definition of dam is the man-made barrier built across a river to hold back the river water for safe retention and store the water or control the water flow. It is totally impervious barrier constructed perpendicular to the flow of the water river with a view of forming the reservoir. Dams are used to control the water level of the reservoir. Next, purpose of dams. What is the purpose? To prevent the flooding during the high water flows and increase the water depth to aid navigation. Generation of hydropower electricity for agriculture and irrigation purposes. To divert the water maintenance requiring sites. Store the water for dry periods. Stream flow regulations for various purposes, fish and wildlife protection and development. Okay. Site selection of for dams construction. Okay, the selection of dam site for constructing a dam should be governed by the following factors. To do all preliminary surveys like engineering, hydrological, geological, and detailed survey and etc. So to know the maximum annual rainfall at the dam site, it should have sufficient space for filtration. It should fulfill the purpose for the irrigation, drinking, etc. The material should be easily available nearby the site. It should be easily accessible throughout the year. The wide and gently sloping valley upstream of the dam side for storage dams, and narrow and steep sloping valley for the downstream sites. A river channel and valley has near flat slopes of upstream dam site, and it leads to the large storage for small dam heights. Where deep reservoir possible, it presently requires less area and lesser land cost, less surface evaporation. The geology should be favorable for foundation, means the foundation can be designed at any site but increases cost, and competent or drug is more suitable. The reservoir area not very sensitive to environment, wildlife, fox, endangered species, historical places and monuments, etc. So, and important one, no species and tectonic activities or active faults in and near the sites. And the no mineral resources in the reservoir area. These are the important factors for site selection for dam construction. Then, geology consideration and dam sites. The success of the dam is not only related to its own safety and stability, but also to the success of associated reservoirs. The selection of a dam site requires extensive geological investigation to ensure the dam and long-term safety, stability, and the reservoir ability to hold the water. In other ways, on construction, if a dam stands firmly but if reservoir leaks profusely, then such a dam is to be treated only as a failure because the purpose for which it was constructed was not served. Next, the important geological requirements which should be considered in the selection of dam or a spout. Okay, the first one is the topography of the site. The second one is the geomorphology of the site. It's like a narrow river valley. And third, occurrence of bedrock at shallow depth. And fourth one, the competent rock to offer a stable foundation for the lithology of the formation. Next one, the geological structures and the area of groundwater conditions and geological hazards. Parts of the dam. Crest, parapet walls, keel, toe, spillway, fluidway, abutments, gallery, freeboard, deck storage level, diversion levels, with all these are parts of dam. The first one, the crest. The top of the dam and some cases these may be used to providing a roadway or a walkway over the dam. Parapet walls. The low productive wall on either side of the roadway or walkway on the crest. Keel. The portion of dam in constructed with the ground or a river bed at the upstream side. The portion of the dam in contact with the ground or river bed at a downstream side. Spillway. It is an arrangement made the kind of passage near the top of the dam for the passage of surplus or expensive water from the reservoir. Next, abutment. The valley slopes on either side of a dam, while to which the left and right end of the dam are fixed. Gallery. A level or gently sloping tunnel like a passage. Small room like a space, like a small. Okay, the transverse or longitudinal within the dam, with a drain on the floor for the seepage water. These are generally provided for having the space for drilling, roof holes, and drainage. They may also be used to accommodate the instrumentations for studying the performance of the dam. The opening in the dam near the base, providing to clear the silt accumulation in the reservoir. Freeboard. The space between highest water level in the reservoir and top of the dam. Deck storage level. Level of permanent storage below which the water will not be withdrawn. Diversion tunnel. Tunnel constructed to divert or change the direction of water to bypass the dam's construction site. The dam is built where the river flows through the diversion tunnel. The next types of dams. The type of dam depends upon the condition of dam site and structure and design. There are four types. The first one is gravity dam, the second one is earthen dam, and third one is arch dam, and fourth one is buttress dam. Gravity dam. Gravity dam is a massive sized dam fabricated from concrete or stone masonry. They are designed to hold back large swells of water by using concrete. The weight of the dam is actually able to resist the horizontal thrust of the water pushing against it. This is why it is called a gravity dam. These dams are heavy and massive wall-like structures of concrete in which the whole weight acts vertically downwards. As the entire load is transmitted on the small area of foundation, such dams are constructed where the rocks are competent and stable. The next one, earthen dam. An earthen dam is made up of earth. It's also called embankment rock dam or rock fill dam. Okay, the earth dam is made up of earth materials or soil built up by compacting successive layers of earth used in the most impervious material to form a core and placing more permeable substances on the upstream and downstream. The earthen material dams are constructed where the foundation or underlying materials or rocks are weak to support these masonry dams or where the suitable competent rock are at greater depth. The earth dam resists the forces exerted upon it mainly due to the sheer strength of the soil. They are trapezoidal in shape. Earthen dams are relatively smaller in height but broad at base. The next one, arch dam. An arch dam is a curved incline. It is a convexity towards the upstream side and it transfers the water pressure and other forces mainly to the abutments by the arc action. An arch dam is quite suitable for narrow canals. It's a strong plants which are capable of resisting the thrust produced by the arc action. But now, in recent years, they have been considered even for little wider valleys. The arc dam may have a single curvature and a double curvature in vertical component. Generally, arc dams are small double curvature are more economical and are used in practice. The next one is buttress dam. Buttress means a support that transmits the force from a load or a wall to another supporting structure. Buttress dam is a gravity dam reinforced by structural supports. This type of structure can be considered even if the foundation rocks are little weaker. Buttress dams are with three types. What are the types? The first one is the deck type, and the second one is multiple arch type, and third one is massive head type. Most buttresses dams are made of reinforced concrete and are heavy. pushing the dam into the ground. Okay. The dams are classified based on their function into two main types. What are the types? The first one is storage dam, and the second one is a diversion dam, and third one is detention dam, and the fourth one is coffer dam. Storage dam. What is the storage dam? Storage dams are widely constructed across a river or a stream and a stream with high water discharge to store surplus water. This surplus water stored in the upstream area, these types of dams are essential for various purposes, including hydroelectric power generation, irrigation, and domestic water supply schemes, etc. Diversion dams. Diversion dams are also known as piers or barriers. They are designed to divert the water from the river or streams into the channel or conduits. These types of dams create the necessary pressure. This pressure guides water flow from the wide area to more focused and fine scale distribution. The third type, detention dams. Detention dams are designed to impede or slow down water flow in the downstream areas, acting as effective flood control measures. These types of dams are also referred to as debris dams, as they trap sediments and debris. The fourth type, cover dams. These are temporary enclosures that create a dry workspace. Copper dams can be earthen, rock filled, or cellular, depending on the project needs. By providing a stable and dry platform, copper dams are minimize environmental disruption during the construction of activities. What are the advantages of them? Clean, efficient, and reliable form of energy. When the initial cost is high, they are very inexpensive to operate. Electricity is generated by hydroelectric power plants in the cheapest electricity generated. Dams prevent the floods. Dams supply the water for local drinking needs. Many desert areas can now farm due to the dams and canals that supply the water. Environmental issues. In flat areas, large dams cause the flooding of large tracts of land and destroying the local ecosystems. Dams restricted sediments that are responsible for their fertile land. Demonstrate. Farmers used chemical fertilizers and pesticides to compensate for the loss in productivity. Large dams are breeding groves and for mosquitoes, and cause wide spread of disease. Dams serve as heat sinks, and the water is hotter than the normal river water. This warm water, when released into the river downstream, can affect the animal life. Dams disturb the natural conservation in a waterflow. Dams block migratory fish species from their fun and speeding flights. The water quality can be degraded. The transported of sediments along the river is disrupted. Reservoirs can emit the climate changing greenhouse gases caused submergence of large amount of plants and decaying anaerobic generating greenhouse gases like the methane. Okay. Examples of dam in India. In Bakra Dam, located in Himachal Pradesh, it is a concrete gravity dam. It is one of the largest dams in this India. Nagarjuna Sagar Dam. It located in Telangana state. It's a man-made gravity dam. It is also one of the world's largest man-made dams. And Kerry Dam is located in Uttarakhand state. It is a rockfill embankment dam. It is the highest dam in India. And Idiki, located in Kerala, it is a concrete art dam, one of the first and largest art dam in Asia. Final, Hirakud Dam, it is located in Odisha. It's a composite dam, like Ethel and Mansari. So it is the longest dam in India. Conclusion. Dams have made an important and significant contribution to human development, and the benefits derived from them have been considerable. Dams building has been one of the most disputed topics affecting the environment today. While dams destroy the nature and the people surrounding the area in which they are built, they do provide people with water and products from the water. The solutions are many, but the damages could be decreased depending on the placement of the dam. Thank you.